welcome to the deep dive. Today we're tackling fats, that essential part of our diet that often feels way more confusing than it should be.
Yeah, absolutely. It's a big one.
We've got a pretty solid collection of info here, looking at what fats actually do for us and trying to sort out the real difference between the ones that fuel us well and, well, the ones we might want to watch out for.
Exactly. Our exploration today, it's going to take us through the really critical jobs fats perform. Things like providing energy, building our cells, even creating hormones.
Okay.
And we'll look closely at saturated, unsaturated, the omegas, and we'll touch on trans fats and cholesterol too.
And importantly, especially for listeners focused on fitness and sports, right?
Yeah.
We're zeroing in there.
Yes, definitely. How these different fats impact your performance, your recovery.
Yeah.
That's key.
Okay, let's unpack this right away. Because, if you're into fitness, you're probably dialed into carbs for that quick energy, protein for muscle repair,
Okay.
obvious stuff. But fats, where do they fit in? They sometimes feel like the forgotten macronutrient.
That's a good way to put it.
So our mission today is really to change that. Give you the clear, need-to-know info about fats without getting, totally bogged down in overly complicated science.
Right. So to start, it's maybe helpful to think of lipids, that's the broader category fats belong to, as, well, compounds that just don't mix well with water.
Okay, water insoluble.
Exactly. The dietary fats we're most interested in are triglycerides, mostly. But we'll also touch on fatty acids, phospholipids, cholesterol. They all have important roles.
And our understanding has shifted, hasn't it? Massive.
Oh, hugely. We used to kind of eye fats with suspicion, didn't we? But now, thankfully, we recognize them as absolutely vital nutrients.
And for anyone pushing their limits, gym, field, whatever, this is even more significant.
It really is.
And here's where it gets fascinating for me. Fat is like the marathon runner of your energy sources. It packs more than double the energy of carbs or protein, gram for gram.
9 kilocalories per gram versus 4. It's huge.
So yeah, that quick energy bar has its place, but your fat stores, that's a massive reservoir of fuel, especially for those longer workouts, right?
Precisely. Carbs are your go-to for that initial high-intensity push, sure. But as your activity goes beyond, say, the 20-minute mark, your body increasingly taps into fat.
Okay.
For endurance athletes, this is just a game changer.
But it's not just energy, is it?
Not at all.
Yeah.
Think about your cell membranes. They're largely made of fat. Hormone production. Cholesterol is the essential starting block.
Right.
And those key fat-soluble vitamins, A, D, E, K, you just can't absorb them properly without fat. Plus, fat plays this really crucial role in managing inflammation. Super important for recovery after training.
So let's zoom in on triglycerides then. What exactly are these? Why are they everywhere?
Okay, so triglycerides are the main form of fat in our diet, about 95% of what we eat. And it's also how our bodies primarily store energy. Picture one glycerol molecule holding onto 3 fatty acids. Now, the type of those fatty acids, that's what determines if it's a solid fat like butter or a liquid oil like olive oil.
And these fatty acids, they're not all created equal, I'm guessing.
Not at all. They differ in 2 main ways. One is the length of their carbon chain, short, medium, or long. The other is their degree of saturation.
Saturation meaning
the presence or absence of double bonds between the carbon atoms. And that saturation level makes a huge difference in how they behave.
Okay, let's start with saturated fatty acids, SFAs. What makes them saturated?
Okay, SFAs. They have no double bonds in their carbon chain. So they're saturated with hydrogen atoms, basically.
Oh, okay.
And because there are no double bonds, they have this straight, linear structure that lets them pack together really tightly, very efficiently.
Which is why they're solid at room temperature.
Exactly. Think butter, lard, that solid block of coconut oil in the pantry.
Right. And where do we find these mostly?
Animal products are big sources. Yeah. Butter, cheese, whole milk, fatty cuts of meat, lard, but also certain plant oils that are solid coconut, palm kernel oil. And they often, sneak into processed foods, baked goods that use butter or shortening.
Okay, but we hear about different kinds of saturated fats. Lauric acid, palmitic acid. Are they all the same in terms of health effects?
That's a really, really important point. It's nuanced. They're all saturated, yes, but common ones like lauric, myristic, palmitic, and stearic acid, they can have different impacts.
How so?
Well, myristic and palmitic acids, for example, they're known to have a more significant effect on raising LDL cholesterol, the bad cholesterol.
Okay.
But then you have stearic acid and the shorter chain ones, but they seem to have a more neutral effect on cholesterol levels.
Yeah.
So yeah, it's not just a simple good versus bad story, even within the saturated fat category.
It's good to clarify. Okay, shifting gears.
Yeah.
Unsaturated fatty acids. What's the key difference here? Why are they liquid?
Unsaturated fats have one or more double bonds in their carbon chain. These double bonds create kinks or bends,
Ah, like a bend in the road.
kind of. And these kinks prevent them from packing together as tightly as saturated fats. This looser packing is what makes them liquid at room temperature. Oils.
Got it. And you mentioned cis and trans isomers earlier. Why are those important to understand?
Right, so this refers to how the hydrogen atoms are arranged around those double bonds. In cis isomers, that's the natural form in most healthy unsaturated fats. The hydrogens are on the same side of the bond. This creates a more pronounced bend.
Okay.
In trans isomers, the hydrogens are on opposite sides. This makes the chain straighter, actually more like a saturated fat in shape.
And that changes how they act in the body.
Dramatically. It seems like a small structural tweak, but it hugely affects how they behave. Think natural plant oils, the cis form, generally heart-healthy. Those industrially produced trans fats, potentially quite harmful.
Okay, so unsaturated fats get broken down further too. Let's start with monounsaturated fatty acids, MUFAs.
Right, MUFAs, exactly one double bond. A big group here is the omega-9 family. That single double bond is 9 carbons in from the omega end.
And oleic acid is the main one.
Oleic acid, yeah, that's the most common MUFA in our diets. Interestingly, our bodies can actually make omega-9s, so they're considered non-essential. We don't have to get them from food.
Where do we find good sources of MUFAs then?
Think olive oil, definitely. Canola oil, peanut oil, those high oleic sunflower and safflower oils. Avocados, of course.
Love avocados.
Yeah. And nuts like almonds, cashews, seeds like pumpkin, sesame. Even red meat and dairy have some MUFAs, usually alongside saturated fats. So yeah, that handful of nuts post-gym, good dose of MUFAs.
Okay, now for the polyunsaturated fats, the PUFAs, this is where omega-6 and omega-3 come in, right? The ones everyone talks about.
Exactly. PUFAs, 2 or more double bonds. And where that first double bond sits, counting from the omega end, determines if it's omega-6 or omega-3.
And both families have essential fatty acids, ones we must eat.
Correct. Our bodies just can't make them from scratch because we lack the enzymes to put that first double bond in the right place. So diet is the only way.
Let's tackle omega-6s first. What's the key one there?
Linoleic acid, LA. That's the parent omega-6. It's essential. Once we eat LA, our bodies can convert it into other omega-6s like arachidonic acid, AA.
Which we also get directly from food.
Yeah, AA is also in meat, eggs, dairy. But LA itself, it's abundant in many plant oils: corn, soybean, safflower, sunflower, cottonseed, peanut oils, nuts, seeds too.
So it's pretty common in Western diets then.
Very common. These oils are everywhere in processed foods, so our intake tends to be quite high.
Okay, and now the famous omega-3s, alpha-linolenic acid, ALA is the parent there.
That's right. ALA is the essential omega-3, the starting point for this series. Now, our bodies can technically convert ALA into the longer chain omega-3s, EPA, and DHA. These are incredibly important.
There's always a but.
There's a big but. The conversion process in humans is frankly pretty inefficient. Often less than 10% gets converted to EPA, and even less makes it to DHA.
Wow, okay.
Which is why EPA and DHA are often called conditionally essential. It's generally much better, more reliable to get them directly from your diet.
So if our bodies aren't great at making EPA and DHA from ALA, where do we get them directly? Fish, right?
Fatty cold water fish, that's the jackpot. Salmon, mackerel, herring, sardines, tuna, fish oils, krill oil supplements too. And for a plant-based option, algal oil is excellent.
And ALA sources, the parent omega-3.
Primarily plants. Flax seeds and flax oil are famous for it. Chia seeds, walnuts, hemp seeds and oil, soybeans, canola oil. Even leafy greens have small amounts. And interestingly, grass-fed beef usually has a bit more ALA than grain-fed.
It's really becoming clear how these tiny structural differences, chain length, saturation, cis strands, dictate everything. Their properties, their jobs in the body.
Absolutely. Its structure dictates function right down to the molecular level. Saturated fats make membranes more rigid. Unsaturated fats, especially PUFAs like DHA, make them more fluid, vital for nerves, eyes, cell signaling.
And just to reiterate, LA and ALA are truly essential. EPA DHA, conditionally essential because of that poor conversion.
Exactly. You need direct sources of EPA and DHA for optimal levels, realistically.
Okay, we have to talk trans fats properly now. What's the latest thinking on these?
Right, trans fatty acids. They're unsaturated technically, but they have that trans double bond configuration we talked about.
Makes them straighter, more like saturated fats.
Correct. And they tend to behave more like saturated fats in the body, often worse. We mainly see 2 types. Industrial trans fats, these are from partially hydrogenating vegetable oils.
To make them solid, right? Like old margarines, shortenings.
Exactly. For shelf life, texture. Found in some older margarines, baked goods, fried foods. But thankfully, due to overwhelming evidence of harm, they've been largely removed or drastically reduced in many places.
Good. And the other type?
Ruminant trans fats. These occur naturally in small amounts in meat and dairy from animals like cows and sheep. The evidence suggests these don't carry the same health risks as the industrial ones.
Okay, good distinction. Now, cholesterol. Often lumped in with fats, but you said it's a sterol.
Correct. It's a sterol. Waxy, fat-light substance, distinctive four-ring structure, but absolutely essential.
Essential for what?
Building cell membranes, brain function, making bile acids for fat digestion, synthesizing all our steroid hormones, sex hormones, cortisol, and even making vitamin D.
Wow. So we make it ourselves and eat it.
Both. Our liver makes a lot of it. We also get it from animal foods, only egg yolks, meat, poultry, fish, full-fat dairy. Plants have plant sterols, but not cholesterol itself.
And the whole LDL HDL thing, good versus bad cholesterol.
That's about how it's transported. Lipoproteins carry it. LDL, low-density lipoprotein, carries it from the liver out to cells. High levels are linked to plaque buildup, hence bad. HDL, high-density lipoprotein, carries it away from tissues back to the liver for removal protective, hence good.
But the focus on dietary cholesterol has lessened a bit.
Yeah, the thinking has evolved. The impact of the cholesterol you eat on your blood cholesterol levels varies quite a bit between people. The current focus is much more on your overall dietary pattern, especially your saturated and trans fat intake, rather than just strictly limiting dietary cholesterol itself.
Okay. And one last category. Phospholipids. Don't hear much about them day to day.
Yeah, but they're super important. Structurally similar to triglycerides, but instead of 3 fatty acids, they have 2 fatty acids and a phosphate group. Lecithin is a common example.
And their job?
Critical for all cell membranes, especially abundant in the brain and nervous system. They're also key components of those lipoproteins that transport fats and cholesterol, and they play a role in how the liver handles fat.
Where do we find them?
Eggs are a good source. Liver, soybeans, peanuts.
Okay, wow. That's a fantastic breakdown of the different types. Now, let's really hone in on why they're so indispensable, especially for active listeners. What are the prime functions?
Well, number one has to be energy. As we said, most concentrated source, 9 kilocal per gram. Super efficient fuel storage.
Right.
During exercise, carbs give that initial burst. But as you keep going, especially at lower to moderate intensities, fat becomes the dominant fuel.
And trained people get better at using fat.
Much better. They even use the fat stored right inside their muscles, intramuscular triglycerides or IMTGs, more effectively. This helps spare their glycogen stores for when they really need that high-intensity power. But remember, fat burning needs oxygen. It's aerobic.
So fat isn't just sitting there. It's a dynamic fuel vital for endurance. What else? Cellular structure.
Absolutely fundamental. Phospholipids, cholesterol, fatty acids, they are the literal building blocks of every cell membrane in your body.
And the type of fat matters for the membrane.
Hugely. Unsaturated fats, especially PUFAs like DHA and MUFAs like oleic acid, make membranes more fluid. That's critical for nerve cells, retinas, immune cells, muscle cell signaling.
And saturated fats
make membranes more rigid. The balance is key. And this lipid makeup affects all the proteins embedded in the membrane, enzymes, transporters, receptors. It influences how cells talk to each other.
Like DHA and nerves.
Perfect example. Essential for transmitting nerve impulses. Or the fatty acids in immune cells, influencing how they respond to inflammation. It's intricate.
It really is. What about hormones? You mentioned cholesterol.
Critical. Cholesterol is the starting point for all steroid hormones. Testosterone, estrogen, cortisol, aldosterone, all derived from cholesterol.
And the essential fatty acids.
They're precursors too. Omega-6s and omega-3s get converted into signaling molecules called eicosanoids. These regulate tons of stuff. Inflammation, blood pressure, clotting, pain.
And they can have opposing effects.
Often, yes. Omega-3 derived ones, along with other molecules like resolvins, tend to help resolve inflammation, which is crucial for recovery. While the overall impact of dietary fat on systemic hormone levels is complex, getting enough fat is definitely important for hormonal balance, especially for athletes.
And the vitamin connection, fat-soluble vitamins.
Yep, A, D, E, and K. You need dietary fat to absorb them properly from your gut. They need to be emulsified and packaged into little carriers called micelles, which requires fat.
So low-fat diets could lead to deficiencies.
They absolutely can. And these vitamins are critical vision, bone health, immune function, antioxidant protection, blood clotting. You need them. Healthy fats help you unlock their benefits.
And beyond the internal chemistry, fat has physical roles too, right? Insulation.
Definitely. Stored body fat insulates us, keeps us warm, and protects our vital organs like padding.
And satiety, feeling full.
Big role there.
Idiot.
Dietary fat contributes significantly to satiety, helping regulate appetite. Plus, let's be honest, fat adds flavor and texture to food, making it enjoyable.
Absolutely. Okay, so fats are clearly essential, not villains, especially for active people. So how does this translate into practical choices? If someone's hitting the gym regularly, what should their overall fat intake look like?
Yeah, for active folks, fat is still that key energy source, especially for longer sessions. And trained athletes get better at using it, sparing glycogen. So the general advice is around 20–35% of total daily calories from fat.
That's a pretty wide range.
It is. Depends on the individual, their training, their goals. Maybe around 1.0 to 2.0 grams per kilogram of body weight. The really crucial thing is not to consistently go below that 20% mark.
Why not? What happens then?
You risk compromising your intake of essential fatty acids, you hinder fat-soluble vitamin absorption, and you can negatively impact hormone production.
Plus, you need fat to replenish those intramuscular fat stores.
Okay, don't go below 20%. And within that 20–35%, what types should active people prioritize?
Definitely focus on unsaturated fats, the MUFAs and PUFAs. Olive oil, avocados, nuts, seeds, fatty fish. Limit saturated fats. The recommendation is usually less than 10% of total calories. And basically eliminate industrial trans fats. Gone.
Right.
And make sure you're getting enough of those essential ones, linoleic acid, omega-6, and alpha-linolenic acid, omega-3. But always remember, fat intake needs context. Balance it with overall energy needs, enough carbs for fuel, enough protein for repair.
So high-quality fats support health, hormones, optimal function for active people. Makes sense. Exactly. Extreme low-fat approaches are generally not a good idea for athletes.
Okay, let's talk specifically about omega-3s in athletes. We hear a lot about recovery benefits. What's the science say?
Omega-3s, particularly EPA and DHA, do show real promise here. They have these anti-inflammatory and pro-resolving properties.
Meaning they help calm down inflammation after exercise?
Essentially, yes.
Yeah.
They might help mitigate that exercise-induced inflammation and maybe reduce DOMS, that delayed onset muscle soreness. Some studies show reduced soreness, maybe lower markers of muscle damage, especially in untrained people or with higher doses.
What about muscle growth? Does it help build muscle?
That's where it's less clear. Some early acute studies suggested a boost to muscle protein synthesis, but longer-term studies and bigger reviews, they generally suggest omega-3s don't significantly increase muscle growth on their own in healthy younger adults who are already getting enough protein and calories.
So, not a magic muscle builder.
Probably not directly. But they might help preserve muscle during periods of injury or inactivity, maybe make muscles more sensitive to growth signals. And the anti-inflammatory effects could certainly aid tissue repair.
Any other potential benefits for athletes? Endurance?
Some hints maybe. Enhanced oxygen efficiency, blood flow, maybe better heart rate recovery. But the impact on actual performance outcomes is pretty inconsistent in studies. They might support immune function, maybe offer some neuroprotection in contact sports.
Okay, so the main potential benefit seems to be around recovery and resilience, managing inflammation, soreness, maybe helping during injury.
That seems to be where the strongest potential lies right now. Supporting recovery, cardiovascular health, immune function. Direct performance or hypertrophy benefits are less certain for well-nourished athletes.
Got it. What about dietary fat and hormones like testosterone? Crucial for athletes.
Yeah, important area. We know adequate testosterone is vital for muscle strength recovery, and cholesterol is the precursor.
So does eating more fat or certain fats boost testosterone?
Well, one thing is pretty consistent. Very low-fat diets, under 20% of calories, tend to decrease testosterone levels in men compared to higher fat diets, say over 35%.
So message again, athletes shouldn't restrict fat too much.
Exactly. Avoid extreme low fat. Now, the effects of specific fat types, that's much murkier. Some observational studies hint maybe MUFAs or SFAs are positively linked, maybe PUFAs inversely linked, but intervention studies don't consistently back this up.
So eating more olive oil won't necessarily boost T levels.
The evidence isn't strong enough to say that definitively. Some tiny hints from preliminary research that maybe omega-3s or CLA could influence synthesis, but it's very limited human data.
What seems to matter most then?
Honestly, overall energy availability. Being in a calorie deficit suppresses testosterone significantly. So the main takeaway is ensure adequate total fat, 20–35%, and sufficient overall calories, Focusing on specific fat types for hormone manipulation needs way more research in athletes.
Okay, practical advice. Let's look at a couple of specific strategies often talked about. Keto diets and MCT oil for performance. Keto first.
Right, ketogenic diet. Very low carb, high fat, moderate protein. Forces the body into ketosis, burning ketones from fat for fuel. Definitely increases fat oxidation.
But does it help performance?
For endurance, it seems you might be able to maintain low to moderate intensity performance after you adapt, but it generally impairs high intensity performance.
Why?
It seems to reduce the exercise economy, basically makes you less efficient at higher efforts. Studies show decreased time to exhaustion, slower race times at high intensity.
So not great for most competitive sports.
Generally not. Maybe a niche use for some ultra-endurance folks worried about GI issues with carbs, but you have to weigh that against the high-intensity limits for strength power. Performance seems mostly maintained, maybe some mixed results for sprints. Muscle growth effects are inconsistent if protein is matched.
Any other considerations? Health impacts.
It often leads to fat loss, which can be a goal. But potential downsides, too. Some people see LDL cholesterol go up. Long-term cardiovascular effects in athletes aren't really known. And then there's the keto flu during adaptation.
So the verdict on keto for athletes?
Generally not recommended as a performance enhancer for most, mainly due to that high-intensity impairment. Careful planning needed if considered for specific niches.
Okay. What about MCT oil? Medium-chain triglycerides, marketed as quick energy.
Yeah, the idea is they're absorbed fast, go straight to the liver, get burned quickly for energy or ketones, bypassing the usual fat transport system. So maybe quick fuel, maybe spares glycogen.
Does it work?
The science, looking at systematic reviews, shows little to no consistent ergogenic benefit for endurance performance in trained athletes.
Really, despite the hype.
Yeah. No consistent improvements in performance metrics like time to exhaustion or VO2 max. Doesn't seem to significantly change fuel use during exercise in trained individuals.
Any potential uses at all?
Maybe some very limited evidence it could slightly increase fat oxidation at lower intensities, but more so in sedentary people. Maybe slightly eases keto induction symptoms. But a key downside is GI distress, stomach pain, diarrhea, especially with higher doses.
So MCT oil for performance?
Not considered an effective ergogenic aid for endurance or significantly altering fuel metabolism in trained athletes based on current evidence.
Okay, that's really helpful clarity on those specific strategies. So bringing this all together, wrapping up our deep dive, it sounds like the message is clear. Fats are essential, absolutely vital.
Absolutely.
And for optimizing health, performance, especially if you're active, it really comes down to quality over just quantity, right? Understanding the differences.
Precisely. Understand saturated, unsaturated trans fats. Recognize their roles: energy, cell, hormones, vitamins. Be mindful of cooking. Choose stable oils. Don't overheat them.
And for active folks,
Ensure adequate total fat intake, that 20-35% range. Prioritize those healthy, unsaturated fats, especially the omega-3s, from sources like fish or algae for recovery, inflammation management, overall health, and balance it all with your energy needs, your carbs, your protein.
so as you, the listener, think about your next meal or snack, hopefully these insights help. Consider how your FEP choices can fuel both your well-being and your performance goals.
Yeah, and remember, the best approach is often personalized. It might take some exploring to find what works optimally for your individual needs and lifestyle.
Definitely. Well, thanks for joining us for this deep dive into the fascinating and sometimes confusing world of fats.